This video covers Unit 6.8 Part 2, Anti-Differentiation Rules with the Fundamental Theorem of Calculus. This one will be a short one. So from the last video, we took antiderivatives. Let's do it with this example here. So I am going to write my constant out front. And I know that this can be changed to x to the 1/2 power. And another simplification is to rewrite the denominator as a negative exponent. So taking my antiderivative rules, I do have an exponent. I'm going to add 1 to that exponent and then divide by the new exponent. So negative 1/2 plus 1 is equal to 1/2. So this is going to be 3 x to the 1/2 divided by 1/2. And then if I simplify that, I'm going to keep this as square root of x, but then I'm going to change this to a multiplication and then reciprocate that and put it outside. And then the final simplification is to say this is sit square root of x plus c. And there is my antiderivative. Now, in the integral above, we call this an indefinite integral. This is called indefinite because it doesn't have boundaries. It's just an integral with no a and b. So this just finds the antiderivative of the function. Now, the problem with it is that it doesn't have any context. It doesn't do anything tangible. It's just for the sake of trying to find the antiderivative. Now, if I add some boundaries on here, like you see here, we call that the definite integral because it does have a specific area. Indefinite has no specific area. It's just the antiderivative, but a definite integral is going to give you a numerical value. Let's do this. So we know the fundamental theorem of calculus, which basically says if I take an integral of a derivative, those cancel out. I can just plug in a and b, and I get this part here. And if this is not the derivative, if it's just the integral from a to b, I write this as capital F of b minus capital F of a. And again, that represents the antiderivative. So we just found this from the answer above. This was 6 root x plus c. Now, I do want to evaluate this from 1 to 9. So I'm going to substitute in 9 and then subtract it from 1. So 6 times root 9 plus c minus 6 times root 1 plus c. And again, from your theorem over here, right, this top boundary 9, so this is f of 9, because it's the antiderivative with 9 plugged in, minus f of 1, so just like we're showing here, from a to b. Now, if I simplify this, I'm going to get 6 times, what is that, 3? So that's 18 plus c, minus, and then again, square root of 1 is 1 times 6. So that is 6 plus c. Now, if I simplify, I'm going to get 18 plus c minus 6 minus c. And again, that's because we distribute that negative through. Notice here how my constants canceled out. And I'm just left with 18 minus 6, which is 12. And there you go. That is the definite integral from 1 to 9 of 3 divided by square root of x. So that's the area under the curve. If I had to draw it, again, I don't know what this function is, but from 1 to 9, the area there is going to be 12. And this wouldn't be arbitrary. You would actually graph that, and then the area from 1 to 9 would be 12. Now, one important thing to notice is if you notice your c's, they cancel out. And that's what the note I wrote over here. When you're doing definite integrals, you don't need to include the constant c because it cancels out when you subtract. because you have c here, and then you're going to minus it from the same c here, same constant, and so they cancel out. And so there's only 4 short examples. It's basically just taking the integral and then substituting in 5 and 1, or substituting in your boundaries. So let's do my integral. So the exponent of the x is a 1. I'm going to add 1 to it, which would be a 2, and then divide by 2. Subtract. Then we're going to take the integral of 3, which is just 3x. If I simplify that, I'm going to get x squared, and then the 4 and the 2's cancel. So I'm going to get 2x squared minus 3x. Now, I am going to evaluate that from 5 to 1, and the way we write that is with a vertical line with our boundaries. So here, I'm going to substitute 5 into here and here. Subtract, then I'm going to substitute 1 in for x. Simplifying this, I'm going to get 25 times 2, which is 50, minus 15. Here I'm going to get 1 squared, which is 1, times 2, minus 3. And so this is 50 minus 15 is 35, minus negative 1. And so that is just going to be 36. So that is the area under the curve of that function. Example 2. Let's rewrite our exponents as negative 2 minus 3x to the negative 3. So taking the integrals of each piece separately, if I add 1 to this, I'm going to get negative 1 divided by negative 1. Subtract 3. My next piece, I add 1 to that, and I get x to the negative 2 divided by negative 2. And to simplify, this is going to be negative 1 over x plus, because again we have our negative and our negative, 3 over 2x squared. The x squared goes to the bottom, and this just turns into a positive. And I'm going to evaluate that from 2 to 4. So first, let's substitute 4 into here and here. And then we're going to substitute 2 into here, and then finish our integral. So this is going to be 16 times 2, which is 32. And then over here we have 2 squared, which is 4, times 2 is 8. Now simplifying, if I multiply this by 8 and this by 8, this will become 32 on bottom. And then I'll have negative 8 plus 3, which is negative 5. Subtract. And I might as well do the same thing here. Get these both to be 32. So that would be timesing by 16 and timesing by 16. So that's negative 16 plus, and if I times this by 4 and the top by 4, I get 12. So finishing this, that's negative 4 over 32. And then this turns into plus 4. So I'm just going to get negative 1 over 32 as my final answer. So on this one, you can switch the boundaries if you need to. It does not matter. In this case, it only really matters when you're doing graphs. But if I take my integral, the integral of e to the x is just e to the x. And then the integral of 2 is going to be plus 2x. Let's evaluate that from negative 2 to 0. So plugging in negative 2, I'm going to get e to the negative 2 minus 4x, or technically plus 2 times negative 2. And if I plug in 0, I'm going to get 1 plus 0. So 1 over e squared minus 4 minus, and then again, this is 1 plus 0. So this is going to be 1 over e squared minus 5 is my answer. Okay, last problem. Let's rewrite this. I'm going to rewrite this as 3 times 1 over x minus 2 cosine of x. So taking the integral here, the integral of 1 over x is log. And the integral of cosine is sine of x. And we're going to plug in e to 1. So plugging in e, this will be 3 log of e minus 2 sine of e. So substituting e, we're going to get 3 log of e minus 2 sine of e. Subtract 3 log of 1 minus 2 sine of 1. Now, from here, I know that this is going to equal 1. Log of 1 is 0. So this is going to be 3, because it's 3 times 1, minus 2 sine of e. Subtract. Now, I know this is 0, because log of 1 is 0. This minus will turn this into a plus. We have 2 sine of 1. And there is my integral.